All right, stats class. We have kind of an ambitious lesson today. This may take a little bit of time to actually get through. So I'll go ahead and tell you in advance that this one's going to be one of the longer ones. I know I said that I don't like, videos that are more than 45 minutes. Really, I don't even like, more than 20 minutes. But I want to go ahead and cram a bunch of topics into this and get through it. So there will be one more video to follow this up and finish up this chapter. But for now, we're going to go ahead and focus on these topics. So we start this video with a problem, and you're going to answer it. You're going to need your calculator. So go ahead and grab your Inspire. You're going to be making you're going to be creating the summary statistics. So here is the question. I'll pause the video and you'll be able to answer this question. But the reason we're going over this is because you're going to have a test question, very much like what you're seeing here, where it gives you a stem and leaf plot, which I think we're still learning how to create those. So we have a stem and leaf plot, and it wants you to find the summary statistics. Now on the test, it may actually just say find the median or find different individual statistics. But what I would like you to do is find all of these. Now the last video the last lesson that I made was how to find them, and hopefully you have your notes on that. And I want to go ahead and show what the agenda is for this video. So this is our summary statistics practice problem, and then we're going to talk about all of the ideas over here, okay, on that list that is blue. Okay, so I'm gonna go ahead and pause the video. You're going to find the summary statistics, and then and we'll see if you got them correct. All right, so you had time to get that answered. Let's talk about how you should have gone about working this. So on your Inspire, you would press Home, New Document is what we want to create, List and Spreadsheets. And if we read this problem, it says this is about the vote, electoral college votes. So you want to name your list something. It could be X. I'm going to name it votes. And then we're going to start typing this in. Let me move my list here. Reduce that. There we go. So we have all of our data over here. And how we read this, we get the key. 1, 5 would be 15, so 0, 3 would be 3. So we're just going to repeat that, and we can count 1, 2, 3, 4, 5, 6, 7, 8 threes, and we want to type every single one of them. There we go. We do the same thing with the 4s. There's 5 of them. 1, 2, 3, 4, 5. Then we go 5 5s. So, oh, I did that wrong. Hold on. There's 5 4s. So 4. There we go. So it's very difficult. It's very easy to make a mistake when you're doing this. So you got to be very careful. See, I even made a mistake there. So I need 5 5s. There we go. 3 6s. 4 7s. Okay. Then 2 8s. Then 3 9s. Okay. All right, and just like that, I have filled this in. Now you should have 51 rows in your calculator. And now to get the summary statistics, we are just going to go over here to the right. We follow the steps that were written out. It's menu, statistics, stat calculations, one variable statistics. So 411 is what we call that. We hit OK. And we want to change our X list. This is the only thing that gets changed. I want to change it to what I named it. Votes, hit OK, and now we're given all the values. So now I'm going to start writing on this PowerPoint. So I'm going to draw. Here we go. So the mean is we have 10.549. I'm not really going to round it. S of X right here is what we want. 9.5818. Let's scroll down. N is 51. N 51. Minimum is 3. Q1 is 4. Median is 8, 12, and 55. So see if you got those correct. If not, then you may have accidentally typed something in wrong. Okay, so you got to be careful with where you type in. See if you can go back and find your mistake. With a data set this large, 51 is so much. And that's why usually I will actually send out the data files to you guys just to make sure that it's more consistent and you're able to get the right answers. But on the test, that won't be the case. You will actually have to type in these numbers. So we have to make sure that we can get that consistently. All right, so that is our practice for the summary statistics. So we are one topic in, boom. Got an X next to that, we are done. Now, we need to talk about what all of these are because we are going to use these to describe data. Now, obviously, if we were working through this and we said SOCS, S-O-C-S, what would the shape be? Well, you should say skewed to the right because it has this outlier up here. It's longer on the right side. Majority of the data is low. The center, probably around 5, 6, 7-ish in there, which we have our mean at 10.5, our median is 8, which is what we're going to end up using for center. Outlier, pretty easily identified as 55. And then spread, right now we've been using range for that, so it'd be 52 would be the spread. But we're going to change all of this today, our understanding of how we describe distributions, and we're going to be using these numerical descriptions moving forward. So we're going to start with the first term. So we're talking about mean. So I'm going to have you go ahead and write everything that I have highlighted here. Okay, so I'll go ahead and pause, write this down. All right, so we are going to call this X bar. On the other slide, we wrote X bar, and it shows up in your calculator as X bar right here, always. So that's sort of the new notation when we talk about average. Now there's more that I want to discuss about the average as you know it up to this point. It is adding all the values up, dividing by the number of those values, okay, the number of observations. And that's all that you really have ever thought about average. But it holds a very important place in statistics and describing data. Excuse me. This is going to be a measure of center. So I forgot to say this, but above where you are writing this definition for mean, I want you to write measuring center. Okay, so measuring center, that's what we're talking about in this section of the notes. So measuring center, we start with the mean. Mean is going to be a measure of center. Okay. Now here is like the very fancy statistical formula. Okay, this is the Greek letter. This is sigma, so I want you should have drawn this. So we have sigma. This says add them all up, but I think it's easier to remember it as sum since it's the Greek letter S, but you're adding all the observations up. N is your sample size, and we're dividing by that. So that's really all we need to know about mean, okay? And we're very fortunate that the calculator can do that work for us, and that's all I expect moving forward. Sometimes you won't be able to use the calculator, but we'll look at scenarios like that when they come. But most of the time, that's going to be what you can rely on. Next, we're going to talk about still under measuring center. We're talking about the median. This is another measure of center, okay? So the median is the midpoint of a distribution, the number such that half the observations are smaller and half the observations are larger, okay? I'm going to pause, write this down. So we have that. Now, we have two measures of center defined, all right? So if I go back here, we have mean and we have median. Now, depending on the problem, you are going to pick one or the other. It is not both. That would be a good descriptor of your center. We're going to talk about that later, but just understand that given a distribution or a problem like this one specifically, there is a better choice for center between the two of them, mean or median, okay? Next, I want you to draw a line in your notes, title this section measuring spread. You don't have to include this inner quartile range, but I want you to write, we're going to start by writing just a definition, inner quartile range IQR, so you'll write that, and then put that definition down here. This is what it is. And then we want first quartile and third quartile. So I'm going to pause and let you write that in your notes. So go ahead and do that. Okay, and I'm not keeping track of what we've done. So we've got mean, got median. Okay, now we're over the quartiles and IQR. So let's discuss what these are. Before we do that, let's actually pop back to our median. I'm sorry I'm jumping all over the place. I needed to write this because this is going to help us so much with these quartiles. The median, we're going to describe it this way: 50% of the data is below, and 50% of the data is above. So this is actually a perfect definition of center, because we know that 50% of the data is lower than that. It says smaller in the actual definition you wrote. But when we think about it this way, half below, half above, that's going to be very important for, say, like test questions and stuff. That's very common that you'll be asked about median, or what value has 50% of the data above it. So we need to remember that. So to add to our quartile definitions down here, which we're going to make sure we have those written down. We're going to add to quartile 1 here. We're going to call it, or we're going to say, because it is the median of the observations located to the left of the median in the ordered list. So let's actually draw a diagram, okay? Let's say that this is sort of a number line representing our distribution. So if I draw a number right in the center and I say, okay, this is the median, we'll say what percent of the data is from here to here? Well, based on the definition, that would be 50%, okay? What percent of the data is from that point to this point? Well, that would be 50%. So when we talk about quartile 1, going back to this definition, it is the median of the observations located to the left of the actual median. So it is the center of the front half of the data. It's the middle of that front half. So here is our median. If I go to this front half here, cut it down the center, this is quartile 1. Okay? That's how quartiles work. If I were to represent this data with a percent, what percent would that be? Well, it's half of 50, so that's pretty simple, right? 25%. And so this also is 25% right there. And hopefully the name quartiles makes sense when you think about that. Quarters, right? 25 cents. That's what it means. So we're going to say this for this one. It is 25% left, 75% right. So to the left of that value, 25%, to the right is 75%. Quartile 3, it is the median of the observations located to the right of the median in the ordered list. So to the right of the median, the upper half, we're going to split that half in half and break it apart. So from here to here is 25%, 25%, and this is that quartile 3. So these really do represent positions inside of the distribution, where it's located. And it's very important to, when we go through questions, to think about that, okay, from a standpoint of interpreting data, okay? Specifically, we need to talk about this idea called IQR, okay? So IQR, you wrote down how to find it. It is Q3 minus Q1. So here's a question. What percent of the data is in between those? Well, it would be 50%. It is the middle 50%. So when we describe spread moving forward, so if I went back up here and let's say that I wanted to describe the spread, we have been using range, right? But we're going to throw range out. Range no longer is relevant, okay? We're going to put a little star here, and I want you to have written all of this, by the way. IQR is going to replace range. And here's why, okay? Because is this distribution really spread out 52? Like, does that describe how spread that data is? Not really, okay? Let me give a better example. Here are the distributions of the test scores that I had you do last time, where we graphed them. And when we look at the spread of these, there we can say, if we use range, it goes from 87 to 28, which is, I think we already did this last video, but so 59 versus 84 to 44, so versus 54. And these values here really pull the data down, okay? And so does the high value, the high test score here. So if we were able to find the middle 50% and compare those distances, that actually gives us a better idea, because outliers cause problems. If I go back to this outlier is single-handedly making the spread 52, when if we got rid of it, it would be 31, okay? So that's a huge difference. 52, that's 20 votes less as far as the spread if that one's not there. And if we use IQR, that helps us fix that. We're using Q1, which is 4, so from 4 to 12, so the spread is 8. Okay, that's how we would describe that, IQR. So that's going to be our new way to define spread, is IQR. So that's one of our ways of describing spread. So there's more ways that there's one more way we're gonna talk about that's very important. But at this point, we have discussed the quartiles and the meaning of IQR. Now, whenever you are doing your summary statistics, sometimes we are interested in something called the 5-number summary, okay? So what I would like you to do is go ahead and write this. And so 5-number summary, very simple. You just take the list that you got from the calculator, and maybe it's only interested in the minimum, Q1, median, Q3, and maximum. That's all at once. So let's imagine this. I'm going to make this 2. I would like you to write this, and then underneath it, let's put 2, 4, 5, 8, and then the maximum can be 12. So let's say that on the test, they give you a list of numbers separated by commas. So the test will say, the following list of numbers represents the 5-number summary. So on the test, they're not going to be labeled. You actually have to remember what is what. You have to know that 2 is the minimum, and it represents the minimum. This is not something you would type in your calculator and find an average for. It doesn't work that way. These numbers, when the directions say this is the 5-number summary, this is that's what you need to think about. 5 would be the median, okay? So that's just something that I wanted to discuss very quickly. Now, here's also what test questions will say. So for instance, I'm going to ask this question, and I want you to answer it in the video here. What value has 75% of the data above it? All right, so you should have said 4, okay? 4 is quartile 1, and from here over is 75% of the data, okay? Another question would be, what percent of the data is between 12 and 5? That could be a question. So go ahead and answer that. What percent of the data is between 12 and 5? So you should have said 50%, right? Here is the median to the maximum. Median to the maximum is 50%, okay? So that's the idea. And you want to be very you want to have plenty of knowledge about how these percents are broken down within these quartiles and median, maximum, all those. All right, so we're going to go ahead and talk about the final plot type for this section. We've talked about dot plots, stem and leaf plots, which are the most work and for some of us the most complicated. Histograms, which you have to have the correct bin width to make that, or excuse me, the width of the bars have to be set. Now we're going to talk about one of my favorites, which is a box and whisker plot. So draw a line in your notes and write box plots, box and whisker plots, what we have up there. So it says the 5-number summary divides the distribution roughly into quarters, and it leads to a new way to display quantitative data. Okay, I'm going to add a new page here, new slide. I'm sort of taking notes a little bit differently today. And we are going to write down steps for a box plot. And what I'd like you to do, let's go ahead and create the distribution. So make a page, you have your votes here, data and statistics, and let's put our votes in here. Okay, so that's what that distribution looks like as a dot plot. So go ahead and make that. All right, now let's talk about how to make a box and whisker plot. So step 1, put data into a list and spreadsheet. Create a dot plot. That's all going to be sort of one step. This is specifically for the TI Inspire. So data goes in the list and spreadsheet. Done. We already put our data for the votes, 51 of them. Make the dot plot. Boom. That step's done. Next, we want to change the plot type to a box plot. So go in your calculator, menu, plot type, box plot, and there we go. Alrighty. So we have created a box plot. Now run your mouse or your finger over your mouse pad here and highlight, and you'll notice some recognizable symbols. We see Q1, median, Q3, and then we have all these other values out here. So we got to talk about all these dots, okay? Now we had suspected 55 was an outlier, and this graph is actually trying to show us that. So we're going to add a step here. Outliers will show up as dots. All right, so this is a way now, if we go, we're changing our ways about describing these graphs. So first off, center has changed to now being median and mean, okay? Now we have IQR for spread, and now we have a we're going to figure out a method for finding if a value is an outlier. Well, one of the methods would be check your calculator, confirm on there that the box plot reveals that there are outliers. This distribution actually has 4 outliers. All of 4 of these are considered outliers. So let's talk about how the calculator is doing this and figuring out if they are an outlier, because you are going to have questions on your test that are going to require you to use this rule we're about to write down to identify outliers. So here we go. Identifying outliers. We have what's called the 1.5 times IQR rule for outliers. So right here. Go ahead and write that down. I'll pause it. All right. So we call an observation an outlier if it falls more than 1.5 times IQR above the 3rd quartile and below the 1st. So
this is what's going to happen moving forward. We're no longer just going to be guessing if it's an outlier. If the question doesn't give us the information we need, then we will guess and just say it looks like it. But if we have data, we are going to identify very clearly the outliers, okay? And this is how we're going to have to do it. The 1.5 times IQR rule. All right, so let's talk about how this works. And we're going to use our example up here to do this. So I think I can write out here. Yeah, we're going to do that. So let me erase this. All right, so the first thing we want to do is we want to find the IQR. IQR is Q3 minus Q1. There we go. Well, Q3 is 12, Q1 is 4. So 12 minus 4 is equal to 8. So that's our IQR. Now, we want 1.5 times IQR, and then we're going to pause for a second and talk about what to do with that. So we want 1.5 times 8. Some of you might be able to do that in your head. I'll just go ahead and multiply it. So we get 12. All right, so we have that for now. Let's go back down to our rule list here. We call an observation an outlier if it falls more than 1.5 times IQR above the third quartile or below the first quartile. Go ahead and underline those in your definition. This is the rule we want. So we know that it's 8. So I'm going to continue writing on here. So let's take Q1. Okay. We want below Q1 here. So I want to take away, so Q1 for our distribution was 4. And we want Q1 minus 1.5 times IQR. Well, that's going to be 4 take away 12, which gets us negative 8. So any value less than 8 any value less than 8 is an outlier. So we're going to say that values. Sorry about my writing there. I don't like that. I'm going to have to actually redo that. Values below negative 8 are outliers. Now, is that even possible? No, it's actually impossible. You can't have a low outlier in this data set because it starts at 0. You can't have a negative amount of votes. So it was never possible. Let's do the other side though. Where did my slide go? Lost it. What the world? Oh, it's over to the side. I was like, where did it go? Okay, so now we want Q3. Q3 is equal to 12. And any outlier that we have that's high is going to be Q3 plus 1.5 times IQR. So that's going to be 12 plus 12, which is 24. Values above 24. So 24 are outliers. So what did we end up seeing on our graph? Well, 24. So 21 is the highest number that's not an outlier, and then all 27, 31, 34, 55, those are all outliers. So some questions will say determine if it's an outlier, and you don't even have data. They just give you the summary or the 5-number summary, and you can do that with the 5-number summary. But here we thought that 55 would be. We weren't really sure that 27, 31, 34 would be because they fall into the pattern. So that's sort of been what's been holding us back up to this point, is we say if it looks like it's far away from the pattern, it's an outlier. Well, here, even though this is in the pattern, it ends up being an outlier as well. Okay, if we had done this on a dot plot, which we did, let me go back to my dot plot, we might actually be able to identify that on here, but the stem and leaf plot doesn't really show that very well. Okay, the box plot identifies it very clearly, and we can see that's how they're finding those outliers. Okay, so let me put my X's in here. 5-number summary. We've talked about how to create a box and whisker plot, but we're not really done with that yet. We're going to go back to our box and whisker plot, put an X there. We're actually going really fast through this video, which is great. I thought this one was going to be pretty long, but we're doing pretty good so far. Let's talk about how you could draw a box and whisker plot by hand. Okay, that's what I want to talk about now. I'm going to move this up. We'll just sort of throw it up here. That's fine. All right, so let's make a box and whisker plot just from the data that we have. All right, so I'm going to draw I want you to do this in your notes. Draw as flat as you can, a line. Okay. I can draw a line. Hold on. I'm going to make it look better than that. Okay, so insert. First time I've taken or used notes on here. So let's put a line here. Can I edit that? Move it. Okay, let me move this here and here. Perfect. Let's put some numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Probably should have changed my scale. That's fine though. I'm just gonna go ahead and edit this. Sorry for all my OCD people. That's what we're doing right there. We're living with it. So 2 is here, 4, 5. I'm only writing the numbers I need. 9, 10, 11, 12, or 9, 10, 11, 12. All right, that's all I need. Okay, so if we're given the 5-number summary, we can actually make the box and whisker plot by hand. This is what it's going to look like. We start with the median, 5. So I'm going to draw a line straight down from there. There we go. Then we're going to draw a line at Q1 and a line at Q3. And we're going to connect those. Here is the box part of that. Then the remainers, or the remaining numbers, maximum and minimum, we're just going to draw the whiskers out to those. So there's a whisker, and then here's another whisker going that way. When we're doing it by hand like this, which these are super fast, so easy to make if you have the 5-number summary plot. So compared to dot plots, compared to stem and leaf plots for sure, or histograms by hand, the box and whisker plot is the easiest to make. Now by hand with this information, we don't know about the outliers. So we would need the problem to tell us, hey, there is a high outlier at blank. The next highest value that's not is this. And then we'd put dots wherever we needed. So if I needed to put a dot there, I could based on what I get told. But that is how you can create by hand a box and whisker plot. Most of the time, you're going to want to use a Inspire calculator to help you with that. But even this one, like, you could put this in your notes very quickly. It does not take long, even with the outliers out here. Okay, super fast. All right, so now we have cranked through this. And now we're getting to what I would say is the most important topic. We're talking about spread some more. So we're talking about what's called standard deviation. And of all the topics that we learn, this is the one that is the most important, like without a doubt, the most important. And here's going to be our example, or our descriptor. Okay, the standard deviation is the most common measure of spread. It looks at how far each observation is from the mean. So how far each observation is from the mean. So you can just write that really quick. Not a lot there for standard deviation. But we have a longer definition that I'm going to have you write down. You can go ahead and write this thing variance, and then also you'll notice the formula down here. Quite intimidating. Quite intimidating. All right, so you should have that written down now. So the definition, and you will need to know this. There's a test question that asks for this definition, so you need to know what it is. It's the average distance of the observations from their mean. It is calculated by finding an average of the squared differences and then taking the square root. Okay, so let's talk about this a little bit more. Let me make a new slide again, and let's look at just this year's data. Okay, this is this year's test data. I'm going to make it into I'm going to put it into my slide so I can draw on it. And what I'd like you to do, those that are distance learners, I want you to look at this graph and I want you to find your test score. It's going to work. There it is. Okay. So let me enlarge that significantly here. All right. So I want you to find your dot. It's somewhere on here, however you performed on the last test. Okay. And I'm going to insert a line, and this line is going to go where our mean is. So this line is X bar. And so let's pop back up and see what X bar is. Oh, do we have X bar for this? Hold on. I think I have it. Do I have it in here? Oh yeah, okay. 68.23 is for 2020 raw data. 68.23. So let's go back to here. 68.23. Okay. And then let's color that red. Oh yeah, there it is. Okay. So now you have a I want to increase the width, the thickness of it. Whatever, it's fine. Take your point. So let's talk about this. Every single person watching this video has a test score up here. And what I want you to do is I want you to calculate the distance from this red line to your point. So I'm going to pick this person's point right here. So here's that red line. This goes here. So that has a length. It's, and I can't remember what that value is, 77 minus the mean. Okay. Then we can go the other way. Let me paste that. We go over here, it starts there, and we have this person's mean, or distance, and they're below. And then we just keep repeating this process with all the people. So that person's, let's do all the way here. We'll go all the way to the top score. And you'll notice that all these distances will be positive no matter which way we go. So what we're doing is we're taking all those links and we're adding them together, okay? And then we're dividing. All right, here's this slide that had the first definition, which describes sort of the same thing, but we take the deviations, because a deviation is like the distance from something. You deviate from something, you're going away from it, so it's that distance. And then we subtract, or we divide all of these distances by the number of observations. So that we would divide this by 39, because that's how many people took the test. Okay, so that's the main concept. Now, we're not done by a long shot with standard deviation or explaining it, but to help memorize what it is, I've done something pretty special this year. I created a song for this. So we've essentially talked about standard deviation now, so I'm going to put an X here, and we're going to finish this video with this song. So if you didn't know, I play the ukulele and do a little show and tell here, and I'm not going to sing on camera. I actually this isn't the one that I did it in class with. I still have my other uke at school, but we're gonna show a clip from class that happened. This was actually a few days just before I am presenting this video or recording this video in my third period dual credit AP sort of hybrid class. So some of them were singing with me. I wanted them to, but here are the lyrics. These will be in the video. You'll be able to see them. But the black text is sort of the definition. What does it do? It describes a spread of data. How should we define it? It's the average distance from the mean. And that fourth bullet point is actually a test question. Okay, it's the average distance to the mean. So the red text is actually the formula. Okay, the red text is the formula. So we are going to in this video with the song and the performance from class. We'll come back and we'll talk about this a lot more, but I'm going to go ahead and fade over to that, and then we'll end this video with that song.
I need everybody in on this.